Now, in order to further proceed, I need to make it clear that we are going to create a cyclic loading amplitude here. So Python code is going to be utilized from the ebook that I have generated, automating cyclic loading protocol for ABAQUS simulations. So let me write it here. Automating cyclic loading protocol for ABAQUS simulation. A practical guide, a step-by-step guide. So I have compiled this book, and you can find this book on my Gumroad profile as well, right? So here I have explained everything about how I developed this code, and there is a course for it as well. So this contains a detailed explanation of development of the code and how we can use it. So a complete guide is given in this ebook, and I currently have access to this source code that I'm using here, right? So let's go to this code, and sorry, not about this one. Okay, so let's run this code. So I use this here, so that's why I use this quotation here. So let's wait for it, and let's see. It will take some time because it's going to load the libraries and functions, and it will generate a cyclic loading protocol for us, which we are going to use and associate it with this model. So I will create a amplitude and call it repetitive loading, right? From ebook, and continue it here. So now it's asking for the loading cycles. So if you study this paper, this book, I have explained everything here in this ebook, which contain full details of this code, and you can find about all these comments that how I generated these codes functions. So there is a complete playlist, and I'm going to include that playlist to this discussion on this course as well. And every single line that I'm using here, I have generated this code from that. So there are some flags, etc., which I have discussed here. So let's look at here. Go to this function here and enter the number of cycles. So for example, I say I need 100 cycles. So it will generate this code, the cycle profile here. You can see here that how this cyclic loading protocol cycle is generated here. So let's go back to this cyclic function, right? And here we need to look at here that we have generated those cycles. So we need to make an amplitude that is scaled for ABAQUS. So I will call it scaled amplitude, and in order to do that I will need to first copy it and paste it here, right? And it's equal to this divided by maximum of this function. Press enter, click on yes, and let's make it a 4, right? And just drag it down, so we will get a scaled amplitude here, and this is going to be the same as the previous one. So what's happening here? Here we are getting a cyclic loading protocol. If I select this, go to insert, and go to scatter chart, and with sharp edges we can now see here that these are the cycles that are generated in our model. So this is a protocol with constant repetitions, right? So if I go to format, f line going to be 1, and going to be, let's make it this, right? So that's it. Now you can see here that these are the repetitive cycles that are generated here, and these are scaled, right? So what we need to do is we need to just copy these and paste them here. So we got this cyclic loading amplitude here, right? So if you go to the tools, plugins, tools, and amplitude plotter, ABAQUS will apply some smoothing functions to it and then show you those models here. So actually ABAQUS is trying to apply smoothing functions to it, right? So those smoothing functions is making it look different. So we have these functionalities here, and we have to decide what should be the initial function in this model. So this should be in step module. So I should go to the step, and in the step module, let's go to incrementation and make it this one as well, the same incrementation, right? Click on OK. So we have developed this model, and I explained everything related to what we have done in this model, right? Now we have this repetitive loading scenario available with us. So let's go to mesh. So we did this meshing technique here, and then let's go to job and create another job. So call it lab 2. Before that, let me just go to the previous model. What was the name of that job? So yeah, that's job 1. So since we are in the other layer, so we will call it job 2, right? Click on OK. Now this is the phase of data check. So first thing first, let's go to file and click on set working directory, so that we have the same working directory that we are using here, and we should expect this directory here. So again, it's perfect, and we are in lab 2 and in the current directory, right? So this is important if you are working with ABAQUS. So let's apply a data check to see what we are getting in the troubleshooting. So don't worry about this warning. It's because I'm not requesting for history output request here, and it's not necessary. But try to be careful about field output request, because if you are not doing field output request in your model and history output request in your model, so it means that you are actually not interested in getting the results. So there is no meaning for finite element analysis then. You should request something which you are looking for in the response for the getting the load to be an action way, right? So that's important, just like the way I am getting strains and stresses with displacements. So let's see what's going on. So let's go to the job and click on data check. So as I mentioned, don't worry about this warning, just click on yes, and let's troubleshoot it. So I'm expecting some problems and troubleshooting, so that is possible. And you can see here, this is the working directory, so all my files are here. So there will be some warnings about sharing nodes which will appear here, and some printing modules which may appear here as well. If you are working with the current working directory, it is a huge benefit for using the temporary directory, right? Alright, so we have this warning and this warning. We don't need to worry about this warning because it is going to use instantaneous properties. And regarding this warning, the aspect ratio of 639 element exceed 100 to 1. So I know how to cater this warning. So in the next video, what I'm going to do is I'm going to remove these warnings from our model, this first one. But since it is a static analysis, so that's why it's saying that viscoelastic material properties will not be used, but instantaneous will be used. So no worries about this one, right? And let's wait for it, so that what's going on in the model further. Troubleshooting is important. अच्छा, अब इसमें sorry, I switched to Urdu. Alright, so now we have to check what troubleshooting strategies we should be using in order to make the model run smoothly. So let's look at here. And luckily we got this warning only, and I think there is nothing more serious to be worried about. Regarding this element, first you should check your model for the aspect ratio, and these aspect ratios are going to be located in these regions, right? So first let's troubleshoot these issues, like what's going on in this model. So let's go to results. Whenever you are facing such kind of troubleshooting issues, you should try to check your model for every possible warning that is appearing in your model, and you can get this in this region, right? So now this is something we are getting here, and these are the elements that we are not getting useful informations. So now you can see these are the elements and their aspect ratio. The shorter to longer dimensions is exceeding, and it exceeds 100 to 1, which is not allowable. So we can include a further tip or question as well. Right? So we got these two questions in our mind, right? And we have to address these as well. So first let's go to our model. Now we are going to the mesh module, and in the mesh module, first I will try to remove these. So let's remove these, and let's make it 1, 0.5, 0.25. Let's mesh it. So we have approximately 14,000 elements. It's not a bad idea. And let's apply the data check again. So that aspect ratio warning will be removed, right? And we will get a smooth model. Only warning about material will be available, which is informatory warning. And another important aspect in this modeling is, if you are working with repetitive loading, you should look at the last step of your applied load, right? And you should try to check the step module, right? And you should control these regions, or these regions. Other than that, you should try to monitor the solver attempts which you are going to obtain, which you are going to get and obtain in this model. And those are important as well, because if you set a step increment which is very larger as compared to what you are using in the amplitude, a lot of information will be meshed. The solution increment will not attempt that loading protocol repetition, and those will be skipped from your model. And when those are skipped, which means you missed the repetitions, and when you miss the repetition, the loading protocol will not accurately represent your model environment. So you can see here now that aspect region or aspect ratio error is removed here. So we got two questions here, the troubleshooting one and the aspect ratio, right? So I will try to discuss these two in the next video. But before that, let's try to continue our model. And in order to continue, we need to make sure this is now the important troubleshooting environment. This ebook contains detailed discussion on the modeling environment. If you are watching this tutorial, you can contact with me if you are facing any issue. I will try to cooperate with you by guiding you on chat, right? Look at the contents. Those are the contents that I have used. And let me just close this. Python code, and let me just close this book as well, this ebook, and let me just code this Python interpreter, and let me just close this ebook as well, this Excel sheet as well. If the simulation is taking so much time, we can check from the mesh, tools, query, and mesh that how much at this region. First at this, then at this region. Let me repeat it again. First you need to go to the tools, and in the tools you need to select on the query. When you select on query, you need to click on the mesh here, and when you click on the mesh, you will find out this option. So here are a lot of options which you can select, but I am going to select the entire model, and I need to select check on the display detail report, and then I click on done here so that I can get those informations. Click on done, and now you can see that the elements are very high in number, and I usually keep them in between 5,000 to 6,000 or 8,000. So 15,000 are too much, and the specifications of these systems are not good, so that's why I need to change them. Right, so I will try to kill this job. Click on yes, and it won't create any trouble for me. then in this region I will select this instead of this. Let's check on 1, right, and click on OK, just to make things easier for us. So let's wait for it until this job is scaled. So signet and seg term error will appear, which most of the time you use. So let me just try to copy these as well, just in case, if I can save them here, because this is the good way to consider modeling and troubleshooting. So this and this. Control B, right? And now you can see here we got this as well. So I will try to do discussion on this whole process, right, in the next video, and data is increasing in this video. So let's go to submit again. I don't need to apply any data check, sorry, and before that I need to mesh it. So let's submit it. Once the model is refined and only variation and mesh are required, then you don't need to kind of run the data check on and on. I think it's not required. So now it will be a bit speed up, and we will be able to get the message and status files as well. Message file, it's very important. Message file is very good way to consider your model, that what's going on in it. Now you can see here the status file is obtained as well, because I reduced the number of elements. The severe discontinuities errors are occurring here because the problem is we are getting the model in a more perfect way, right? So it's not a big deal if we get any severe discontinuity errors. The mesh are adjusting itself, and nodes are moving back and forth in the model. So let's look at here. Now it's properly working, and luckily I'm not getting any warning in the model, which is a good indication about the status that is developing in the model. And let's wait for it until it is completed, so I can show you how we can change those in our simulations. And I will try to create animations from it as well. I'll try to make it a full-scale model. Make sure that neither the units that I'm using, neither the properties that I'm using are correct, nor the geometry. It's just an assumed model with assumed parameter, and not cited from any literature. So be careful about your own model geometry and material definition, etc., because it's important to check this. There is a phenomena which I'm trying to discuss, just in case if I get the results, and I'm getting the results, right? The file is working fine, right? You can Okay, right. So you can see here I'm getting the results. If I go to option, common, and then feature edges, and I will try to change this to ISO surface to visualize it, right? So you can see it now. With quilt, you can also visualize it like this. And if strain is visualized, we can check the strain as well. We can check the logarithmic strain, we can check the plastic strain. Now if you are not getting any plastic strain, which means that plastic deformation is not occurring in the model, but logarithmic is showing us what's going on in the model, right? So here the model is working fine, and if we try to change it to like 500, we can see that how this road, this is separating in each other, right? So let's say if I simulate it, you can see here with each cycle the deformation is increasing, residual stresses are accumulating in this model. So this wearing and tearing phenomena is occurring in this model. With each repetitive cycle, the strain is increasing. You can see here this model, and the separation in the road profile is occurring as well. So now you can see what's going on in it. Let me show you again the status of the job, which is working fine, right? And in this way you are going to get those details, etc. So these are just temporary assumed simulations, right? I'm not at this stage, I'm not taking any actual material, right? Because I have a special purpose for that. I'm trying to keep them in a case study, because there's a lot that we are going to cover in this course. It's not just a simple course. I'm planning that, for example, if we uh, try to make it more user friendly, we need to make sure that the lectures are in such detail that when you watch this complete course, you will have an idea of how this course is compiled and how it is working, right? So it's not a simple course. It's a trial and error based with labs and theory and all those stuffs. Those are included in this course. So just in case, and then you have an idea of how this is working. So we are going to follow this course content, and this not yet completed. A lot of lectures are missing in it. For example, after module 3, module 2, then we have module 3, right, and module 4 and 5, 6, 7, 8, 9, 10. So these materials that we are watching here, these are not yet compiled in this course. I have not included any theoretical background for it, right? And you can guess that we already have covered approximately 9 lectures with such a detailed way that now you may have confidence of working on flexible pavements. You will have a clear picture in your mind about the flexible pavement, that what you are trying to follow, right? And you will have an idea of how it's working. So it's not that much simple course, right? It's a very detailed course, which we are trying to cover. So 9 lectures are covered, and I think I should continue this discussion in the next lecture. Then I will jump into the other theoretical background, and I will try to cover a detailed way of other materials and temperature sensitivities, for example, aggregate interlocking and viscoelastic properties of asphalt. I will cover all these steps here in a very detailed way. Maybe I will complete this course in 1 month or 2 months. So I have no idea how many lectures I am going to record. Maybe those will be 20 or 30. I don't know. I think I should stop this recording and do discussion on the results in the next video. But I'm waiting for it until it's completed. Now you got the idea. We had 199 increments in the amplitude that we generated from Python to what we are getting here. So this, I was talking about this last increment. This is very important, right? If it is missed, we have missed the last unloading stage here. So before proceeding further, let's just stop this. So I will stop this lecture at this stage, and then in the next video I will try to cover it with explanation.